Hey Eric, what you doing there?
Oh, what's up, John? I'm just doing my physiology project for muscle contraction, and I don't really get it. You think you could help?
Yeah, sure, no problem. I got this.
Well, Eric, you see, the first thing, a muscle contraction, is the neuromuscular junction. This communicates with the synaptic terminal to initiate the muscle contraction process. First, an action potential arrives in the synaptic terminal. The vesicles in the synaptic terminal release acetylcholine into the synaptic cleft. The binding of the acetylcholine to its receptors creates a permeability in the membrane, allowing sodium ions into the cell. The action potential made by the sodium ions travels down the sarcolemma, the membrane of the cell, and into transverse or T tubules. The action potential triggers a massive release of calcium ions. The calcium ions then flood out of the sarcoplasmic reticulum and into the basic functional unit of a muscle contraction, the sarcomere. The sarcomere contains thick myosin and thin actin filaments. The actin filament contains molecules of troponin that cover the active site by holding tropomyosin in place. Calcium attaches to the troponin, stimulating the release of tropomyosin, thus revealing the active site. Myosin heads attach to the active sites of the actin filament, forming a cross bridge. The attached myosin heads pivot toward the center of the sarcomere, pulling the actin and releasing ADP and a phosphate group. An ATP molecule binds to the myosin head, releasing it from the active site. The myosin head resets itself along with the breakdown of an ATP molecule into an ADP plus a phosphate group.
So Eric, now do you think I increased your knowledge of how muscle contractions work?
Actually, I found it in English on the internet.